Hello, ladies and gentlemen. This is Mr. Heron, and I want to just take a day or two, or the equivalent of a day or two, and just kind of review what factoring is. You guys have seen factoring before, although it's been a while. So I just want to kind of do a quick little refresher on factoring and have you do a little practice just to kind of keep your skills sharp and remind you what it is. So now, before we talk about factoring, I want to talk a little bit about a quadratic and kind of where that comes from, because factoring is part of dealing with a quadratic function. So this is a quadratic function. This is what the graph of a quadratic function is. Now, the factoring part has to deal with these two pieces right here, where the graph crosses the x-axis. Okay, so these are called your zeros. Okay, or your roots, and those are where they cross the x-axis. So what we want to be able to do is take a quadratic function and figure out what those two things are without having to graph it. So before we start looking at factoring, let's look at how do we create a quadratic function. Well, we have to have an x squared term, and so we end up multiplying these to get a quadratic. So when I see x plus 3 and x plus 4, and some of you guys might recall something called the box method. And all I do is I write the terms x plus 3 and x plus 4. So then I multiply them to fill in the blank. So this one becomes x times x, or x squared. This one becomes x times 3 for 3x. This bottom left one becomes x times 4 for 4x. And the bottom right becomes 3 times 4, which is also known as 12. So now I did that in different colors on purpose. So I have x squared. Then I can put these two together. I end up getting 3x plus 4x. So that becomes 7x plus 12. There is my quadratic. The one on the right here is actually even a little simpler. This is just old school distribution, x times x and x times 7. So it becomes x squared minus 7x. I'm done. All right, that's all I'm trying to do. So that is putting it together. That is, you're given kind of some roots, you're given some zeros, and you're trying to put together a quadratic that represents those zeros. So now, when we factor, most quadratics, as you can read right here, have the form x squared plus bx plus c, where b and c are numbers. So I use that to kind of figure out what I'm doing. So I focus on c and I look at the factors of that number, manipulate to figure out how I can get a middle term, and then check the signs to make sure you're correct. So for this one, if I see 10, right away I'm looking at factors of 10. And I'm trying to figure out, how can I get 7? Well, I can get 7 using 5 and 2. That's why I circled 5 and 2. So now I need to use 5 and 2, and because these are both positive, my factoring is just going to be x plus 5 and x plus 2. If I multiply it back, if I multiplied these two terms, I should get this to start with. So if I do that, x times x is x squared plus 2x plus 5x plus 10, which is what I started with. There we go. The one on the right here is a little tougher. I need to look at 6. So I have 6 and 1 and 2 and 3. And now I need to figure out how to get a positive 1. Okay, so I have to imagine there's like a little positive 1 there. So 3 and 2 could get me 1 if I have positive 3 and negative 2. So that becomes n squared plus 3. I'm sorry, back up. Should just be n plus 3 and n minus 2. So I get negative 2 there, so that's going to figure out my sign. One of the giveaways, kind of when you're dealing with signs, is kind of looking at all the different possible combinations. So if I've got x squared plus bx plus c, you know, for these two signs, there's only 4 combinations. Plus, plus, minus, plus, plus, minus, minus, minus. All right? These two kind of go together. These two kind of go together. This situation, like if I have x squared plus, 6x plus 5 or something like that. All right? These two kind of go together, and these two kind of go together. So now the way I tell kids is this. I'm looking at this second sign right here. I'm looking at this second sign. If that second sign is positive, is a plus, then in my answer, in my factored answer, then my both signs have to be the same. So if that second sign is addition, so the addition, but both signs need to be the same in my answer. So down here, if I look at the second sign, and the second sign is subtraction, then I'm going to have one of each. I'm going to have an x plus something. I'm going to have an x minus something. So here I'm going to have one of each. So now, let's take a look here. 3x squared plus 8x plus 5. So now I put something in front here. Okay, so I put a number in front of 3, so that's really going to mess with people. So here's all I do. I don't try to get, too clever with this. Here's what I tell kids. All that means is I take 3 times 5. I take first times last. Okay, that obviously gives me 15. So now 15, now mess with factors of this. Figure out factors of 15. Well, I have 15 and 1, 3 and 5. Those are my factors. So now that 5 and 3, that's going to give me 8. So now here's the other piece. I can't just skip ahead and go, oh, it's x plus 5 and x plus 3, and that's my answer. No, that's going to be wrong. This is wrong. Okay? First off, neither one of these x's has a 3 in front of it, and you need a 3. What I need to do, and this is kind of a tough part for some kids, is I need to rewrite this whole thing using 5 and 3. And here's how I do it. 3x, 5x, 5. So I split 3 and 5, 8. I split 8 into 3 and 5. And now I go parentheses, 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 parentheses. Why did I do that? Well, I'm going to use a little thing called factoring by grouping, which is kind of a repeat from algebra. So now I look at this and I go, what's in common here? Well, every one of these has got a 3, and one of these has got an x, so I'm left with x plus 1. Over here, what's in common? Well, both of those have a 5. So I'm left with x plus 1. Now, notice that these are the same. So my factored answer becomes 3x plus 5 and x plus 1. There's my factored answer. And notice the sign thing still holds up. I have plus, plus. That means my signs should be the same, and they're both positive. All right, so now over here, if I take 2 and 3, that's going to be 6 and 1. Well, now I need to get negative 5. Well, to get negative 5, finish off the factors of 6 there. Well, to get negative 5, I could go minus 6 plus 1. Right? So I'm going to go 2x squared minus 6x plus x plus 3. So then I'm going to rewrite that. Yep, negative 6 and 5. So then parentheses, 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 parentheses. First set, what's in common? 2x. Nope, I biffed that. Let me back up. That's not going to work, and I'll tell you why. This still needs to be a positive 6 up here. Positive 6. So that means the only way I can get away with that is if I go negative 3 and negative 2. So this really should be 2x squared minus 2x minus 3x plus 3. That is my fault. I'm sorry. I apologize if you had to erase your paper and rewrite it. But it's better to fix it rather than have you make a mistake. So now, back to where we were, pull out what's in common. So if I pull out 2x, I'm left with x minus 1. Over here, I've got 3x and 3. I'm actually going to pull out a negative 3, and look what this does. I'm left with x. Then I need to change this sign to x minus 1. I did that because pulling out a negative makes it so that these two are exactly the same, which is what I want. If these two are not exactly the same, so like if I had, if I was going along and I had one was x minus 1, the other one was x plus 3, I can't put that together. Since these are the same, now I can. I got to go 2x minus 3 times x minus 1. There's my answer. There's my factored answer. So now, how does it change when I start setting things equal to 0? The answer is not a whole lot. All I do is kind of take one more step. So if I do this one, I start looking at negative 18. How can I get negative 7? Well, if I start looking at factors of 18, well, negative 9 and 2 would give me negative 7. So I go b minus 9 and b plus 2 equals 0. So now to solve, I just set each part equal to 0. And now it's just two one-step equations. So b equals 9 or b equals negative 2. That's all I'm doing. Over here on the right, same kind of idea. I'm just taking my factoring steps, except now at that last piece, I'm going to set each part in equal to 0. So here, my number would be negative 42. So now I've got to start messing around with that. 42 divided by 3 is 14. 6 and 7. I'm trying to get that negative 1 in the middle. Well, negative 7 and 6 would give me negative 1. So now I go 2b squared minus 7b plus 6b minus 21. Again, all I'm doing, rewriting the negative 1 using 7 and 6. Parentheses, 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 parentheses. So this would give me b, 2b minus 7. This would be 3, 2b minus 7 equals 0. So I would be left with b plus 3, 2b minus 7 equals 0. So b would equal 3, or negative 3. B would equal 3.5. Just set each part equal to 0 and solve it. That will do it. All right, if it's equal to 0, that means you can solve it. There's my solutions. Now, how does it change if I've got things on opposite sides here? Well, it's pretty easy. I just move everything over to one side. So I subtract 13m, subtract 28. So I'm left with 6m squared minus 13m minus 28 equals 0. So now it becomes a game 6 and negative 28. That's going to be my that's going to be what I'm looking for. So I think that is going to be about 170, 168. And that's going to be a negative, so I need to play around and somehow get 168 divided by 13, or 168 and find factors of that that are going to give me 13. So I can start playing around with it. 2 and 84, double that, half that. So that's going to be 42. You know, I can go 8 and 21. Well, 8 and 21 is 13. But I got to keep looking around because I've got to get a negative 13. So if I go negative 21 plus 8, that'll do it. So I go 6m squared minus 21m plus 8m minus 28. All right, I'm not going to forget about the equals 0, but I'm just going to leave that out for the time being just so I can finish factoring. It's still there. I'll bring it back in at the end. So 6m minus 21m, I can pull out a 3m. Now I'll be left with 2m minus 7. Over here, I can pull out a 4, and I'll be left with 2m minus 7. So I get 3m plus 4, 2m minus 7. Now I'm going to bring back the equals 0. So now does this fit? Well, I've got minus 28. So that means if I've got a minus here for that second sign, I'm going to have one of each, which is what I have. So then finish this thing off. 3m plus 4 equals 0. 2m minus 7 equals 0. Solve it. It's a two-step equation. This is going to be negative 1 and 1/3. This is going to be 7 over 2, which is going to be 3 and 1/2. So there's my answers. Negative 1 and 1/3 and 3 1/2. All right, I do have one more problem, one more quick one. This guy right here, I'll bring it down over here. Same idea, I'm going to take it all over to one side. So now this is almost like saying minus 0c minus 81. Okay, this is like saying I have 0c. I don't have a middle term, I don't have like an x term. So what this is asking is this: what multiplies to 81 that would get you 0? So if I go 81 and 1, and you know, I can go 9 and 9. Hey, 9 and 9 jumps out at me. Well, negative 81, so that makes that negative 9. So it becomes c minus 9, c plus 9 equals 0. So I have c minus 9 equals 0, c plus 9 equals 0. So my answer becomes 9 and negative 9. There's my answer. Okay, I know that I covered a lot, so please feel free to hit pause, rewatch, and make sure that you know what you're doing. You have seen this before, but don't be afraid to ask questions because factoring will come up.